bit more. The whole idea for everyone is not to learn about motors, it's because you're all being trained what is a motor. So, very important for tonight's session is the theory component about motors. We need to know what are the motors and then starters and the application of the starters. Next week, we're going to spend 3 hours just in calculations. Then I'm going to confuse you a lot. And we're going to talk about input power, output power, torque, speed of the motors. But I'll just give you a bit of an appetizer before we finish tonight's session. So what's very important about tonight's session is we must know what's a motor, what's inside the motor, because they can ask us all of this detail in the exam. So let's see, what is the first thing? Now, in the exam, they can give you a little picture, it looks like that, and they can ask you what type of motor is that. What do you guys think? Do you think that is a squirrel cage motor or a series motor or a universal motor? What do you guys think?
Universal.
Squirrel cage.
Well done. I think so as well. I think it's a universal motor. I hope so. Let's see what the answer says. It's a shaded pole motor. A universal motor looks like that. A universal means AC or DC. So the top one is your shaded pole motor. And the shaded pole motor is a motor which can work on AC and DC. Yes, but believe it or not, your series motor at the bottom is the one in your battery drawers, etc. So guys, let me just see here quickly. No, I haven't got the link yet. Oh, guys, I'm just going to invite one more trainee. It seems like you still haven't got the link. Give me one sec, guys. Oh, that is the register. Golly, the three screens is confusing me. Sorry, guys, for this interruption. There we are. Can you all see the shaded pole motor and the series motor? Right, give me one sec. I just want to invite Tony. Tony. God. Tony. Sorry, guys. I just need to invite all the guys. Some people wants to be in the class. Some can't be in the class because they can't get in. Let me just double check this one. Tony. Tony. Tony McLean. Tony McLean. Go. Right. So the motors you see on the screen is the two single phase motors you can use a lot. So the top one is a motor which is sometimes in little fans inside your computer. The top one, the shaded pole motor, is also one which is used somewhere else, like for example, inside a computer fan, as I said, or kitchen appliances, etc. So we're going to talk about this motor very shortly. This is your series motor. I don't think I've seen it before. It's also called a universal motor, but I'm going to give you more detail very shortly about it. But this motor is the one in your battery drawer and your jigsaw and your sander and all that lovely things. Yeah, comes the first part. And please take note, all this is single phase motors. This one has got a cap and two windings. Can you all see that all motors, coils, yeah, has got 4 turns and 4 turns. So I'm going to teach you that you must understand that motor's 2 windings are exactly the same. We call this a permanent split phase motor. Now this permanent split phase motor has been used in pumps, etc. Now the next one you're going to look is called a standard split phase motor. Have a look at the difference. The one that's got a cap, the one's got a centrifugal switch. The one's got the starting coil or auxiliary coil and the main coil. This one has got auxiliary and the main coil. And the last two I want to add is a capacitor start motor. And the last one is the capacitor start and capacitor run motor. Now I'm going to ask the group, have you guys seen any of the sketches before?
Yeah.
So guys, in the exam, they can ask you, what is the drawing, which of the four drawings is a standard split phase motor? Which of the four drawings is a capacitor start motor? That's one. Or they're going to confuse you even further. They're going to ask you, they blank it out. They blank them all out and say, a capacitor start motor, a standard capacitor start motor, this one. But you don't have the picture. Has it got a cap in it or a centrifugal switch? So, guys, one of the homeworks I want you to do tonight and for the next couple of days is to learn this couple of sketches because in the exam they love to ask you. And what I'm going to do is Control B, no, Shift B, Alt B, no, my PowerPoint didn't go blank. Let me do this again. No, Shift B. Here we are. It goes like that, and it says, given a permanent split phase motor, how do you change the direction of that motor? So can you see they ask you a word, but they don't tell you what it is. And if you don't know what the motor is, you don't know. So there we are. A permanent split phase motor. It's got a capacitor in. Again, if I go like this and I say to you, a universal motor, has it got an armature in it or a rotor? And your answer is, it's got a armature in it. This is your universal motor. So it's important to know all these drawings. Now, if they ask you again, I'm going to go like this again, and I say, your capacitor start capacity run motor, how many capacitors does it have? One, two, or zero? And your answer is two, one, two. So can you all see, if you know your drawings and you know what's in it, you will know everything about the motor. So I'm going to give you a little hint. If you know that, you will be able to answer any single phase question related to motors. And I'm going to give you a clue again. A universal motor, which is this one, does it got brushes or not? And the answer is yes, it's got. The universal motor, does it got a starting and running coil? The answer is no, it's got a series coil. So then they can ask you a shaded pole motor, and if you have a look, it's a top left-hand side one. Does it got a starting coil, running coil, or does it got shading rings? And if you know the drawing, it's got shading rings. So what I'm going to do now, I'm going to drill into every motor, and I'm going to tell you a bit more about it and the things you should know about all this motors, which is very important. Right. Something I'd like to add to you that this motors is also called asynchronous motors. So what's meant by asynchronous? It's got starting coils, running coils, and they synchronize the coils. In other words, one coil lags the other one, and the one coils try to catch the other one. So we've got one magnetic field inside this. So please take note that your series and shaded pole motor does not form part of asynchronous motors. Just high level, nothing deeper than that. So let's have a look bit deeper into this little puppy. What is the name of this motor? Let's click on insert. Can anybody tell me A, B, C, or D?
D.
D.
D. I've got D, 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 D. I've got 5, 6, 7. I will need one mark. Is it A, B, C, or D? You guys are 100% right. This is a shaded pole motor. So a shaded pole will be circled. This is question one, and question one will go green. Right. What type of motor is this, guys? Anybody knows?
Universal. C.
Is it a universal or series motor?
C.
Correct. So that's one way they can ask the exam. They can give you a picture and they can ask you what motor is it. Let's try this one. What motor is that? What do you guys think?
Permanent split. B.
Is it a standard split phase or permanent?
Permanent
I'll
split
give you a
motor.
hint. The split the phases means current splits up. Standard split phase means one coil that runs. Permanent means both coils. So both coils means they will run the cap change of phase angle between the two windings. So this is a permanent split phase motor. The next one, is this a standard split phase motor, permanent split phase motor, a capacitor start motor, or a cap start cap run? I'll give you a hint. It's got
Standard.
nothing to do with caps. Got nothing to do with caps. So it can't be C and D. It can only be A and
B.
B. Permanent split phase means you've got a cap and standard
Standard.
split phase is the correct one. Well done. So guys, do you agree that the drawings is important for all these questions? I see you guys are typing in very good questions, answers for me. I can see you guys are very active here. Parama, Viraj, Brady, well done. Now, what do you guys think is this one? Is it the standard split phase motor, a permanent split phase motor, a cap start motor, or a cap start cap run motor? Well, a cap start cap run needs two caps, so it's not D. Yes, I see good answers. Yeah, I see you guys all tell me it's C, cap start motor. Well done, great stuff. So you all agree that the drawings of this is critical. If you know the drawings of this motor, you will be able to tell me what these motors are. Now, guys, I'll tell you now, you need 5 minutes for the next week every day to draw that six drawings, just rough as guts. And guess what? You will know them by the end for this exam. And that's how I've learned. I've learned to draw them. And I'm going to show you now what I'm going to draw to make your life easier for yourself. Right, last one. What do you guys think is this motor? Is it a standard split phase, permanent split phase, or a cap start, cap run, or just a cap start motor? Well done, Pranama.
C.
Craig, Dirk, Ravender. Well done, guys. The guys who's typing the answers in Viraj. Well done. Brady, great. Jake, Ravi, Matthew, awesome. Connor, yes, well done, Uri. Right, absolutely. It's a cap start, cap run motor. So, guys, it sounds easy if you know the drawing and you know what to do. So, what's very important? You must know the drawings. If you know the drawing, you will know exactly the purpose of each coil. Now, just to help to remember this motor. So this motor is called a shaded pole motor. It's not very strong. I guarantee you that 99% of us will be able to put a finger around that shaft. When you switch it on, the motor will hum. This motor is normally used inside small appliances like fans, kitchen blenders, coffee grinders, tape decks, and also the old data projectors we used to have, or even still have, computer fans. They're all called the shaded pole or motors. Now, can you see that this motor has got a shading rings here at the top and shading rings at the bottom? That's very important because that is a very, very important purpose for this motor. And you'll find out that you must know the reason for that. Right, so if you have a look at the shading pole motor, when I switch power on, a magnetic field is induced in a metal core and it will rotate left around, anti-clockwise, clockwise, anti-clockwise. It does that 50 times a second. Now, if this shading rings wasn't there, the magnetic field would have gone straight through the armature, in this case a rotor. Rotor means that there's no windings, and the motor will not turn. Now, once you change the angle in which the magnetic field cuts the rotating part, then the motor will turn. So the shading poles has got two reasons. One, to create torque, and number two, to start the motor. If you want to change the direction of the motor around, you physically have to take the motor and twist it over. Because this motor, you cannot change phase and neutral to change the direction of this motor. So the shaded pole motor has got a very important part. If this motor turns clockwise and it blows the fan to the right, and you want the motor to blow the fan in the opposite direction, you'll physically take the fan and turn it around. But there is an alternative way you can also do. But not all motors has got that option. You can take that ring there and there, pull it out, and put it in the opposite side. As you guys can see what I've done here. So that is also possible to change the angle in which it chops. That is exactly the same as take the motor and turn it around. The reason I say that is because some motors you cannot physically change the angle by ripping the coils out. You physically have to take the motor and turn it around. Physically take the stator pole motor and turn it around. So there we are. What I need to know about this: one, this motor is designed to operate in kitchens, small appliances, fans, and all that lovely things. You must know where we use this motor, one. Number two, you must know the purpose of the shading rings. And number three, you must know how to change the direction of the motor. So, Brady, I'm going to ask you a question. How will you change the direction of this motor? A, swap phase and neutral around, or B, swap the motor around?
Swap the motor around.
Fantastic. Right, Mr. Bradley White, what's the purpose of the shading rings? A, to look the motor look expensive. B, to create starting torque. Bradley White or Alex?
To
I'll
create
ask you.
starting torque.
Fantastic. That's what I want to hear. So if you know that motor and you look at the picture, you say, change direction of the motor, swap it around, rings, starting torque, boom, that's more than enough. Where will I use it? Dominic Todd, where will I use this motor? A, at the pump running water from building A to B, or inside a kitchen blender? Try Elno or Emily.
Kitchen blender.
Let's try another one. Jared Fogley, Jared Meads, Jed, Jesse, anyone, Jonathan, where will you use the motor? Will you use it to pump water or kitchen blender? Well done, guys. So what's very important, this motor is used in small little loads, which is not very hard to turn. Right, well done, excellent. That's the first motor. Try the second one. The second one is called a universal motor, or in your guys, we learned it's a series motor. Now, in the exam, they can ask you, why is it called a universal motor? Is it because it's AC only? Is it because it's DC only? Or is it because this motor can be used for AC and DC circuits?
Can be used for AC and
You
DC.
can use both.
Yes, well done. Number C is the right answer. It can be used for AC and DC circuits. Right, this motor is a motor which is used inside battery drills or angle grinders or any high speed equipment you're going to use in your work kitchen and all that places, or not work kitchen, in your work offices, on site, etc., etc. Now, this motor has got something which turns this part here. Is that a rotor or an armature?
Armature.
You might know this yet. Right,
Armature.
I'm going to give you the hint. This is how I remember this. Have you guys ever heard about the trade, armature winder? An armature winder is the person who rewire motors. So there we are. It's an armature. It can be rewired. An armature has got windings inside, and a rotor hasn't got. It's got aluminium bars. So you must know that. Right. The next question is, can you see that motor is turning here at the bottom? How am I going to change the direction of this motor? Right, guys, I'm going to make it very simple for you guys and show you the drawing over here. To change direction over here, I either swap the polarity of the armature around, or I swap the polarity of the series coil around. That's all you need to know about this motor. Well, one thing I always pop in is, what's the purpose of the brush or brushes? Now, guys, the brushes is a switch from the series coil through the armature. A brushes is a method for current to flow through an armature. And there we are. Brushes act as a switch. and that will determine for the motor which way to turn as well. So there we are. By changing the direction of the armature around or changing the direction of the series coil. In other words, the polarity can be swapped. So, 3 questions. Question 1, A or B? How do we change the direction of this motor? A, swap phase and neutral around, or B, swap the armature around?
Swap amateur.
Amateur.
Armature. So guys, again, if you know the motor, the picture, you know what to do. But if I don't say the picture and I do this, if I do that and I say it's a universal motor, how do you change direction? A, swap the motor around, or B, swap the armature around. There's no universal motor, swap the armature around or the series coil around. So it's very, very important to know the drawing in mind and where you can use it, how do you change direction, and last but not least, the function of certain parts. Right, here comes one of the asynchronous motors we're going to cover. Now, you'll see that I've drawn a red coil and a blue coil inside this motor. Now, this shows you that the cap is in the red coil. So if you have a look, the cap is with the red coil. The blue is by itself. Can you all see in this picture, there's 4 curlies for the red and 4 curlies for the blue. That tells me each coil is exactly the same size. So that is one of the characteristics of a permanent split phase motor. All the coils are equal in size. So if the motor didn't have a capacitor and you switch it on, the motor will just vibrate. It can't turn. So the cap has got 2 purposes. One, to create torque, make the motor stronger, but also to create direction. So if you want to move the direction of this motor, you're going to move the capacitor somewhere. Wait, we'll explain that very shortly. So firstly, the cap you're going to use in here is called a solid dielectric capacitor. Solid dielectric design is that this cap can always be in the circuit. This motor will always have a running and starting coil inside its process when it runs. So to reverse this motor's direction, you move the cap from the starting coil to the running coil. Where will I use this motor? Places where you need a high torque for starting and a high torque for running. In other words, you want this motor to be strong. So when this motor starts, it starts with a cap. When it runs with a cap. So it's always strong. Gentlemen, ladies, what is the purpose of the capacitor? A, to change direction, yes or no?
Yes.
Oh,
To create starting torque. To create starting torque, what we guys saying?
Yes.
Yes. Right, somebody just take me and I'll say, nope. Online only. Somebody asked me if there's class at E-Tech tonight. I don't think we did say that. Sorry guys, mentioned last week. Sorry guys, I'm just texting this one student. Right, so if you look at this motor, a permanent split phase motor, does it have a cap in it? The answer should say yes. The permanent split phase motor, is there starting and running coil? Yes. Are they equal in size? Yes. How do you change direction? Move the cap. What's the purpose of this? Is to pump liquid or turn strong, run strong, start strong. Now, guys, back in Africa where I came from, we had lawnmowers since 1984. I bought a lawnmower which was 1800 watts, a nice motor. Inside, it was a permanent split phase motor. So when I start the motor, it must be strong enough to turn and cut the lawn. And when it runs, it will run strong as well. Sorry, guys, I just want to see who takes me now. All right. I'm just going to send one more link out to someone. So give me 1 sec and I'll rock and roll again. So guys, a permanent split phase motor, what's important for you guys is to know what's inside this motor. I'll go to the next slide so you guys can see more. Come on, there we are. Right, this motor don't have a capacitor in it. It's got a centrifugal switch in it. So what happens now is this motor is not as strong when it starts, but this motor has got something interesting in the system. And this motor has got a running coil and a starting coil. And as you can see here, the starting coil is bigger than the running coil. Can you all see that?
Yes.
So what's the difference between a permanent split phase motor and a standard split phase motor? So a permanent split phase motor has got a starting coil and running coil, and they are exactly the same size. Can you all see that? If you look at a standard split phase motor, it also got a starting and running coil. But this motor, because the motor hasn't got a cap to create direction, it needs two resistances, different size, to give the motor direction. Sorry guys, I just invited a trainee which couldn't get in. For some reason he couldn't get what he had to. Let me just let him in, admit. There we are. So to recap, a permanent split phase motor, which is the one you saw previously, has got two coils. They are equal in size with a cap. As per a standard split phase motor, also got two coils, a starting coil and a running coil, or auxiliary or mains. It's got the same meaning, but the difference is they got different resistances. So the resistance difference of the motor will determine eventually the direction of the motor, and I'll show you that to you guys shortly. But there's a very interesting thing in here. It's got a centrifugal switch. Who can tell me, based on your experience, what is the purpose of a centrifugal switch? Okay, I'm going to give you two answers. You're going to give me the right one. A is to cut open the starting coil so that it doesn't burn out. Or B is to change the direction of the motor. What do you guys think is the answer? I'm going to say that again.
A.
Oh, excuse me. A,
It's A.
is it, there's no C yet. So there's two purposes for this motor. Or the centrifuge could one reason. Is it to start the motor? Obviously, yes, because if it's open, it won't start. Yes. But will it stop the motor? Or the centrifugal switch, will it cut out the starting coil? So, guys, it cuts out the starting coil. Well done, Jake. The reason for that, this coil, this 20 ohm coil, has got a very high resistance. Now, if this resistance is always in the system, it will heat up and burn out. So we say that the starting coil is short time rated. It cannot be always in a system. It needs to stop, it needs to cut out. Now, the only way to cut it out is by using a centrifugal switch. Now, if you look at this one, the centrifugal switch, when the motor reaches around about 75% the speed of the motor, the centrifugal switch will open and it will cut out the starting coil. Now, as the motor slows down, the centrifugal will close and eventually the motor will stop if you take the power away. But very important, the centrifugal switch must open if the starting coil want to survive the sequence. Now, what I'm going to do is just show you how do we change the direction of this motor. You can either swap the direction of the starting coil around, or you can swap the direction of the running coil around, but not both. Now you guys will say, where do I use this motor? Gentlemen and ladies, it can also pump water, but it's not as strong as a permanent split phase motor because soon If you put a capacitor in it, the motor is strong. Now, this motor has got two coils. Are they the same size? Yes or no? Is the starting coil and running coil the same size?
No.
Well done. So that means to change direction, you swap around the polarity of the starting or the running coil. What's the purpose of the centrifugal switch? Can you see it cuts out the starting coil? Apparently in the exam, they say it cuts out the starting coil, it cuts out the running coil, or C, it stops the motor. So guys, it cuts out the starting coil or auxiliary coil. Starting auxiliary is the same meaning. Main coil or running coil has got the same meaning. That's why I put this here on my PowerPoint by saying main or running, auxiliary or starting, because in the exam they can give you any answer. Now, here comes a multi-million dollar question, and I want to ask someone, Matthew France, can you see this as a centrifugal switch?
Yeah.
In its normal position, when the power is off, is it closed or open? I'll give you a hint. Look at the picture.
It's closed.
Fantastic. What will open it? A, my fingers, or B, the speed in which the motor turns, the centrifugal forces?
B.
Well done. And now here comes the last question. What do you think is wrong when this motor starts? It turns, picks up speed, and then when the switch opens, the motor stops. And when the motor clicks and the switch closes, the motor starts again. What do you guys think is wrong?
There. I
A,
can't. Thank good.
sorry guys, I'm just going to mute you guys.
Yeah.
Oh, there we are. We just muted. So I'm going to say this again. What is broken if this motor starts, stops, starts, stops, starts, stops? A, you've got a broken centrifugal switch. B, we've got a broken starting coil. Or C, we've got a broken running coil. What do you think is broken? If you switch this motor on, the motor starts, stop, stop, stop. Those who said running coil, well done. Guys, have a look at my picture again. If you break this coil, the motor will start. When that switch opens, the motor will stop because this coil is not there. And then when the switch closes, the motor will start again. And when the motor hits a certain speed, the switch opens, the motor will stop again. So the centrifugal switch is there to cut out the starting coil. But if there was no running coil, the motor will stop again. Now, the next question. If you start the motor and you don't have a starting coil, A, the motor will start. B, the motor will just hum and burn out. If the starting coil or the switch was open when you started,
it will not start.
the motor will not start, the motor will hum and eventually burn out. So that's very important. So you need two coils because that creates a phase angle in resistance and the centrifugal switch will cut it out. So if you know this two very well, then the next two motors is going to be a piece of pie. I'm going to show you guys this. One, the motor we're going to do now is called a standard split phase motor, or you guys know it as a capacitor start motor. The motor starts with a cap, but what does the centrifugal switch do? Does it cut out the starting coil? Does it cut out the running coil? Or does it cut out the starting coil and the cap? Be careful. Listen what I said. Does it cut out the starting coil? B, the running coil? Or C, the cap and the starting coil? Can you see the switch cuts out both? So this motor starts like that nearly, but it runs only on this coil. So have a look. When this motor starts, it starts with a cap. In other words, it's strong. Well done, Graham. Well done. So if this motor starts, It starts with a cap. In other words, it's strong in starting. But when it runs like that one, because that one is the same as that one in running. I'm going to say that again. If this motor starts, just give me one thing, guys. Forget. Thank you. Sorry, guys. If I go back to this permanent split phase or the capacitor start motor, please have a look. When the motor starts, it starts with a centrifugal switch, a cap, and a starting coil with a running coil. The centrifugal switch is to cut out the cap and the starting coil. But because the starting coil has got a cap in it, it creates starting torque. So a coil in series with a winding is in series give torque, not direction. Now, how do we change the direction of this standard split phase motor where the coil resistances was different? If you guys can see, we swap the coils around. If I come to this one, exactly the same. Look, 20 ohm, 5 ohm. As soon as the resistances is not the same, look at the windings. are drawn at 5 and 3. When you see this, you swap the coils around. And I'm going to show it to you guys now. There is a 20 ohm, 5 ohm coil. That cap is short-term rated. In other words, we call this one electrolytic capacitor, not a dielectric capacitor like the previous one we did. So the electric capacitor is a short-term rated cap. So once the motor starts, the capacitor must cut out. Because if it doesn't cut out, one, the winding is going to burn out, but two, the cap is going to bugger up as well. So there's two reasons what the cap must do in this case. Again, look at the picture. The switch must open to cut out both, otherwise both will suffocate. The cap is short-term rated. The switch is a switch which works with centrifugal forces. The capacitor there is for starting torque. And the last thing is to change direction, you either swap the direction of the starting coil around or the running coil. Oops, I want to go back. Or the running coil. I just show you two pictures there, not three. So to recap, the cap creates torque. The switch open the starting coil and the cap. When the motor runs, it only runs on the main coil. To change direction, you have to swap the polarity either of the starting coil around or the running coil around, but not both. Okay with that? How do I memorize this? I just look at the picture and I say to myself, cap, starting, winding. If you don't know, there's 6 drawings. You quickly draw it and you will then fill it in. Easy questions, guys. In my handbook, everybody should have my handbook, except those that lives in Auckland, which will come and pick it up at my place or at work next week. So what's important, look at the questions and it will help you. What's very important about this motor, where will I use it? Also, where you need to push something, but when it runs, momentum can take it, like water. You can have this in an air conditioner. But if I say to you a concrete mixer, no, you can't. Because a concrete mixer need to be very strong in starting, but just strong in running. So what I'm going to do now is to show you the last motor, and then we're going to put them all together and summarize it. So this motor's got 2 capacitors. This capacitor is a starting cap, and obviously you've got a running cap. There's 2 capacitors. The centrifugal switch will do something. There's my drawing, a starting cap and a running cap. The centrifugal switch, does it cut out the auxiliary coil or the running coil or the cap and the starting coil, or D, only the starting cap? Can anybody have a guess? What does the cap centrifugal switch cut out? Is it the starting coil only? Is it the running coil? Or is it just the starting cap?
Just the starting gauge.
Excuse me. If you look nicely, it cuts out the cap only. Because when that switch opens, see there? If that switch opens, then the circuit is still like that. So very interesting about this motor. When the motor starts, there's 2 capacitors. In other words, this motor is very strong and starting. When the motor runs, the motor is strong and running. But now I gave you guys the clue away. Can you see that both coils are equal in size? Now you tell me, how are we going to change the direction of this motor if coils are equal in size? I will show you now in a picture, which is easier to understand. Now, to recap, this motor has got two coils. The starting coil and running coils are equal in size. If you have a look, the only way to change the direction of this motor is a physical to move the cap to the running coil. Right. The purpose of the centrifugal switch is to cut out the starting cap, because this starting cap, as you can see, is short-term rated, and the electrolytic capacitor must be stopped, otherwise it's going to blow up. This cap is called a solid dielectric cap. It can always be in the system. I'll give you a hint. If you zoom into this cap, this will be a 250 volt cap, and this one will be a 440 volt cap. It's just how they rate it. So if you look at the four drawings, which I just did, I'm going to recap everything for you in a picture which I started off. That one is called a shaded pole motor. The shaded pole motor has got two shading rings to give the motor starting torque, and obviously if you swap it around, direction. But if you take this motor and you want to change direction, you physically have to swap the motor around. The next one is called a universal or series motor. The universal or series motor is a motor which can work on AC or DC. This motor has got a coil in series with the armature. The armature's got windings in. This one is one used in battery drills and all that lovely things, where your previous one is a shaded pole motor, which you will use in little kitchen appliances like blenders, etc. Now, those who sat this exam before, the examiner has asked, where will he use this motor, the shaded pole? Will he use it in a concrete mixer, or will you use it in a blender in the kitchen? They ask you questions like that. Think logically. You must know the picture. Now we're going to talk about our asynchronous motors, starting coil, running coil with a rotor. This motor is a permanent split phase motor with a capacitor. Both windings are equal in size. To change the direction of this motor, you move the capacitor. This motor is called a permanent split phase, no, standard split phase motor, apologize, standard split phase motor. This motor needs a centrifugal switch to cut out the starting coil. The starting coil is short-term rated. So what it does, it cuts it out and it will only run on the running coil. Now guys, a question in the exam will be, what else can I use instead of a centrifugal switch? Can I use a timer? Say yes. Yes. Can I use a current coil? Yes. Can I use a voltage coil? Yes. So a current coil and a voltage coil is a little coil connected. When the voltage becomes a certain amount, it will open. A current coil means when current flows there, it will open. So that is just things they can use. But please take note, the most common one everyone will use is called a centrifugal switch, which work with centrifugal forces. Now, if I come to the third last one, or second last one, it's called a capacitor start motor. This capacitor start motor has got a starting coil, a running coil, a cap, and a centrifugal switch. The cap's purpose is for torque. The centrifugal switch cuts out the starting coil and the cap. And B and C, and the last one is the two coils is there for starting and for running. Now, guys, if you look at this motor, excuse me, when this motor starts, it technically starts like this one with a cap in the circuit. But when it runs like this one, which the circuit, this part has been taken away. So technically, these two motors are the same strength, if you think about it, when it starts. But when it runs, only this motor will be strong because there's a cap still in the system. This two will be equal in size when it runs, in strength. That strength we call torque. Right. And the last puppy is a capacitor start, capacitor run motor. If you have a look at this one, the caps are there totally for starting torque as well as running torque. So when this motor starts, the two caps in parallel make this motor's face angle way smaller, stronger. So it is very strong when it starts. So this motor is the strongest in starting. I will use this motor for concrete mixers, big compressors, big air conditioners, etc., etc. So when this motor runs, it runs exactly the same as a permanent split phase motor. Have a look, cap with two coils, cap with two coils, and that is called asynchronous motors. I want you guys to go and learn the pictures. Now I'm going to go back to each of the 6 and just to tell you how do we change direction. The top left shaded pole, we swap the motor around. The series motor, I swap the polarity of the series coil or armature around. The permanent split phase motor, I move the cap. A standard split phase motor, I change the polarity of the starting or running coil around, but not both. The cap start motor, because the coils are not the same, look, 5 and 2, we swap the polarity of the windings and that will change the direction of the motor. And the last one is a cap start, cap run motor. Because both windings are the same, I move the caps from the starting coil and we put it in the running coil, and that will also change the direction of the motor. Cool. That is a mouthful. You can get up to 5, maybe 10 questions from that. Now, if you go through my book, I've captured a lot of questions from it. Now, I'm going to do this. I love to do this. And I'm going to say to you guys, right, this motor you saw over here, if I go like this and I say to you, a capacitor start motor, a cap start motor, how did it change direction? So you don't know, you can't see it. So you must know the drawing in your mind to know that you're going to swap the polarity of the starting or running coil around. If I go for the last time a blanket, how are you going to change that direction of a shaded pole motor? And they can say, move the cap, swap the supply around, or C, change the direction by moving the motor from one and turn it around. And there it is, swap the motor around. So if you know the pictures of the 6, you will be able to answer any of the questions I've just given you. Is that clear to everyone? Any questions? Sounds good. Clear as mud, hey, Graham? So, guys, motors you're going to get. Now I'm slowly going to go a little bit deeper and a bit of theory. But, guys, as you all can see, I love to give you pictures. When I see a picture, it makes sense to me. Now, that little motor, what motor is that? We all know it's a permanent split phase motor. That one, we all know it is a standard split phase motor. That one is a cap start motor. This one is called a cap start, cap run motor. They all has got stators in them. That is the red and blue coils. All of them has got a rotor in them. Some of them has got centrifugal switches and some of them has got capacitors. So in the exam, they can ask you a cap start motor, what is all the components in it? So you must know all of them will have a stator in it. All of them will have a rotor in it. Some will have centrifugal switches and some will have capacitors. So if you know the drawing and you know what they are, you will be able to tell me what's inside. Now, in my other book, which you guys got, you'll see that this motor has got different parts. Now, if you look at this part turning, you'll know that is one of the 4 motors. Now, if you go further and you look nicely, this motor's got no capacitors in it. So that tells me it's most probably a standard split phase motor. But what you should know is this is called a shaft. This is called the driving end. This is called the non-driving end. That's where the fan is connected. This motor's got a terminal box. This motor's got a foot piece. This part here in the front is called the end shields. So there's an end shield in the driving end, and there's an end shield in the non-driving end. This part here is a keyway with a key inside, and that key locked up with a load, and that will prevent the motor not to slip inside the bearings of the load. Now, at the back, there's a fan and a fan cover. Do you all know the purpose of the fan? Right, Parama, a shaded pole motor has got a rotor. I want to go back to show you. A shaded pole motor has got like a little rotor like this. A shaded pole. A series motor will, a series or a universal motor will have an armature. So in all of them, it's only the series motor who's got an armature. So guys, what's the purpose of the fan? A, is it to blow air across the motor or to cool down the building? Fantastic, Graham. Is to cool the motor. Well done. Wonderful, Tracy. You guys are writing great answers down. So the fan, yes, Finn, you are right. And also Josh, it blows air over the fins. Now, there's a fan cover. A, what's the purpose of the fan cover? A, is to prevent you to damage your fingers when you touch the motor. B, is to blow air over the motor. Or C, both, what I just said to you. Well done, Josh. The fan cover will prevent you to get hurt. In other words, there goes the fingers. But B, it also pushes the air over the motor. So guys, if you don't have a fan cover on the motor's going to burn out. It will blow air everywhere except over the motor. Sad side, but unfortunately that's how it quickly crumbles. So very, very important. If you ever see a motor and the fan cover is not correctly connected, then this motor is going to burn out. So very important. The fan cover is very, very, very important for this motor. Now guys, just to finish off, the side where the bearing, where the shaft is, we call this the DE side, the driving inside. The other side is called the non-driving inside. It's just a name you can learn on the motor. And obviously this knuckle up the top is just to put something around to lift the motor out of the place wherever you want to use it. Right, that is fantastic so far. So if you have a look, a permanent split phase motor, what are the things inside a permanent split phase motor? Yes, it needs a centrifugal switch. Yes, it needs a rotor. The third thing is, yes, it needs a cap. Right, a standard split phase motor. It needs a stator. It needs a rotor. No, yep, rotor, not an armature, a rotor. And C, a centrifugal switch. Right, the centrifugal switch is normally around the shaft. You'll see that the shaft turns, and as the shaft turns, there's little weights there, and it'll push the weights open. So the centrifugal switch is mounted on the shaft on the motor. Cool. Right, try the next one, a cap start motor. Does it got a stator in it? Yes. Does it got a rotor in it? Yes. Does it got a centrifugal switch in it? Yes. Does it got one cap in it? Yes. All good with that? Right. And the last one is a cap start, cap run motor. Does it got a stator in it? Yes. Does it got a rotor in it? Yes. Does it got a centrifugal switch in it? Yes. Does it got a cap start? Yes. And a cap run. Right, Graham, I know that you said on the shaft, it all depends. But this motor normally have the centrifugal switch mounted on the shaft, but the bracket is on the body of the motor. So when the motor starts turning, the weights open and it pushes the centrifugal switches, the switch itself open. So it's a little device which is mounted on the shaft. So as the motor turns, it opens the weights and it opens the contact on the fixed part. So partially on the shaft and partially on the motor. But the weights which kicks out must be on the shaft because otherwise the motor cannot. Obviously, the centrifugal forces cannot open the weight on the motor or on the centrifugal switch. So the reason I put a lot of emphasis on this, it's one of the questions that people get in the exam a lot now. What components is inside this motor? What components is inside that motor? So I keep on telling you all the goody things which you should know to do well in this exam. Now you guys who got my book will see that there's a lot of questions like this in the exam. I try to force you to know the different parts inside this motor. So this is just the inside of the motor. If you go to the previous sketch, there is all the drawings. So that drawing shows you what's in it, and this one will tell you physically how does the components look like. Please guys, go this week and go learn the theory. You all got the books, you can do these questions, don't do the calculations. Leave the calculations for next week. Right, that is single phase. Now, single phase will be single phase. They cannot ask you anything except the 6 motors I just did. To recap, cap start, cap run, cap start only, permanent split phase, standard split phase. Then you get a series motor, which is also called a universal motor. And the last one is called a, does anybody know? Can anybody tell me what that little 6 one, which I get in blenders? The one I get in kitchen appliances. What motor is that? It's not a series motor.
Shaded pole.
Anybody? Shaded pole motor. Well done. So the shaded pole motor is that motor with the 2 rings on it. Can anybody remember what's the purpose of the 2 rings? A, change the direction of the motor. B, starting torque. C, all of them. Yeah, all of them, all of them, all of them.
See.
Starting torque and direction. Well done, well done, well done. So guys, I just had another student who sat the exam yesterday. One guy sat regs and one guy sat theory. And the guy who sat the theory, he said to me, what caught him is that when it comes to the motor questions, he had to read the question well because it's a bit tricky, but eventually did well because I think he got 78% in the exam. But the main thing is he must read the questions, guys. That is very important. Right, let's look at the 3-phase motor. If I give you a 3-phase motor, it means there's 3 sets of coils in it, a red coil, a white coil, and a blue coil. All good? A red coil, a white coil, and a blue coil. How are you going to change the direction of the motor? How are you going to make the motor go clockwise to anti-clockwise? Does anybody know?
Change the phase around.
Swap any 2 wires around. Is that what you guys said?
Change to
Changing. Yes, well done. Line 1, line 2, line 3. If you have a look what I'm going to do, line 2, line 1, line 3. I swap the red and white around and look, the motor's turning the opposite direction. So the motor will turn clockwise and then anti-clockwise. So that's very important. Cool. So it will turn one direction and then opposite direction, right? Very important. And if it doesn't turn the opposite direction, you haven't swapped 2 phases around. Only 2. Not all of them, just red and white, or red and blue, or white and blue. Doesn't matter which 2. Now, here comes the question to everyone. Do I do it at the plug, or do I do it on the motor? There's only one answer, guys. And 3000, chapter 8 under testing say, all sockets must be the same. So there's only one place where you can do it. You change the direction on the motor. Well done, Graham and Jake. That's awesome. So yes, Alex, on the motor, if you swap the plug around, then the motor will, you most probably will have 3 or 4 motors on the plug, and the motor will not turn around. I'm just letting someone in here. He's knocking at the door. Right. Any questions on the changing the direction of a 3-phase induction motor? So give me one second. I want to do this. Yeah. So that is a 3-phase induction motor. To change the direction, you're going to swap line 1 with line 2, 1 or 3, or 2 and 3 around. Cool. Well done. Right. A 3-phase motor can only be connected 2 ways. Star, which looks like a star, or delta, triangle. Right, that is the only 2 ways. Now, which one of the 2 connections do you guys think is the strongest? Star or delta?
Delta.
Delta. They ask you that. How many times stronger is delta than star? 1 times, 2 times, or 3 times? Yes, Ravinda, you're right. 3 times. Well done. So in delta, the motor is 3 times stronger. I showed you guys that when we did chapter 1, when I say to you, the motor with the load which was in star, the power is 3 times more in delta. We will do that again when we do calculations. Not tonight, next week. Now, if you look at this motor, if I give you a star connected motor, can you all see with this star connected motor, they got line 1 to A, line 2 to B, line 3 to C, and then A1, B1, C1 is joined up. Now, firstly, let's have a look at some coils on this motor. A and A1, A and A1, B and B1, B and B1, C and C1, C and C1. So when I start this motor, it's very important to know that the A, B's, and C's is not mixed up with A1, B1, and C1. Otherwise, this motor will single phase. In other words, it will growl like a bulldog eating razor blades. So, no, we do not swap the A's and A1s around. I'll show you guys. You bring the supply leads, line 1, line 2, or line 3. You're swapping 1 and 2 around. You're not swapping the coils around. Please take note. In the exam, they give you an option, swapping the coil around. No, we swap the supply leads around on the motor. So if you look at this lovely question, line 1 goes to A, line 2 goes to B, line 3 goes to C. What do I do here? Can anybody tell me with A1, B1, and C1? A, do we leave it open? Or B, I short it out?
Short it out.
Right, you always say short it out.
Sort it out.
Yes, look there. Can you see they're all linked? Hey, Jake, well done. Can you see here? It's shorted out. So that tells me this motor is connected in the star. Please have a look nicely. Line 1A, line 1A, line 2B, line 2B, line 3C, line 3C. Then A1, B1, C1 is shorted out. A1, B1, C1 is shorted out. This connection is called a star connection. Right, delta. Look what I did in color. Line 1 goes to A and C1. Come on, show you what I'm going to do here. I'm going to bring line 1. I'll first put you the coils in, which we already did earlier with the previous connection. A and A1, B and B1, C and C1. But now look what I'm going to do with red. I'm going to put red on A. But where is A also connected?
C1.
C1. But before I do that, I just want to show you B and C. Now, A and C1 is shorted. Look there, C1. Can you see that B and A1 are shorted? And C and B1, that is a delta connection. So, not all motors can run in star and in delta. Some motors is not designed to run on high currents. So that word means we can only connect them in star. Some motors can run in star or delta. The nameplate will tell us that. Now, this question pops up in the exam. So, how will this question be asked in the exam? The question is, they give you this top left or top right. And when you look at them, they ask you which one is star, left or right, A or B. So, very important. You must know when you see a short between A1, B1, C1, that is star. When you see A and C1 shorted out, B and A1 shorted out, C and B1 shorted out, you know that's delta. Does that make sense to you guys? I
Yes.
hope so. So what's important here as well, we'll talk about it later again. Star is 3 times weaker than delta. Delta is 3 times stronger than star. Cool with that? How many bridge pieces does star have? 2 bridge pieces or 3 bridge pieces? Star, look there, there's a little bridge piece, and there's a little bridge piece. Well done, 2, Jake. Delta, Brady, how many does delta have? 3. Hooray, well done. Delta's got 3, star's got 2. They asked that in the exam. How many shorts is inside star? Look, 1, 2. Delta, 1, 2, 3. So guys, there's a lot of questions they can ask you on visuals. And look at this visual. What is this connection? Star or delta? If you see a triangle, is it star or delta? Well done, Rajva. That is delta. Now, do you all know that delta means the motor can be connected in star or delta? But if it's star, it's 3 times weaker. If it's delta, it's 3 times stronger. Now, look at this one. If you ever see a nameplate and it says 230/400, please take note. The motor can only be in star. It tells me 1 coil 230, 2 coils 400. When this motor is only delta, the motor's going to burn out. Please take note. 230/400 is star only. A triangle means either star or delta, but it's normally connected in delta so that this motor is at max because you want the maximum strength for this motor. Otherwise, this motor will not do its proper job. Right. So, before I go to the next topic, what do we call the strength of a motor? Is it called wattage or torque?
Talk.
Torque. What is wattage? Is it heat or strength? Well, you'll learn that heat is actually wattage. It's the amount of heat generated. That is the easiest to explain, measured in watts. Strength is measured in torque. Now, I always say how warmer the motor is, how more losses there are. That is input output wattage. Heat create losses. We'll talk about that next week. But when you look at this lovely motor, there is your torque curve. Those who have studied this exam many years ago, you had to draw this torque graph and label it, and it was worth 10 marks. Now they give you the drawing and they ask you, where is the load? You say, right, there is the load. Now, this point here is called the starting torque. Now, I'm going to ask Graham this question. Graham, if I take the starting torque and I put it low behind the load over here, will the motor start or will it just hum? It's not strong enough. If the load is above the starting torque.
Just
That's right. Well done. So, guys, the starting torque must be above the load. So, I'm going to give you 2 values. If the load was 5 Newton meter, the starting torque must be more than 5. Makes sense, eh? That question is an exam. They will say, what will happen with the motor if the load is bigger than the starting torque? the motor will burn out. If you do my questions on motors, you will see it. As easy as that. Right, the next thing is pull out torque. Now guys, I'm a very visual person, and that's why you guys will do well in this exam. If you look at this visual, look what I'm going to spell. T-O-P. What does T-O-P stand for? Top. Top. See that? T-O-P. Pull out torque. There's the top. That is your pull out torque. We always call this, when I was an apprentice, I used to say, this is the point of no return. When that motor hits the maximum, the motor will turn. Take an aeroplane, a jumbo jet, when it takes off, the pilot, I've got a friend which is a pilot and he's also an electrician, and he said to me, when you hit a certain speed on that runway and there's an engine failure, you have to go off because you're not going to have enough runway to stop. Well, except if both engines failed, then you've got no choice to stop. But what I try to say is, same with the motor. When the motor has built up a torque and it hits the top, the torque will drop and it will drop to full load torque. And all what's going to happen, it will be the torque which will keep the load just going. And that is the torque we're going to calculate. We always calculate the torque of the motor when it runs. That is the torque we're going to calculate. Right, so we got starting torque, we got pull out torque, and we got full load torque. Now here comes a couple of extra little things, which is not hard. The full load torque is the it's the torque to keep the load going. You need a higher torque to start it, but then the torque will drop due to the speed of the motor, because speed has got a big relationship with torque, because there's a formula. Power output is 2 pi nt over 60. N stands for rotor speed. Speed and torque has got to go. So if you look at the bottom, your synchronous speed is ns, your rotor speed is nr. The difference between the two is called slip. So that tells you everything about a motor speed and strength. So if I give you a motor and I say to you, the starting torque is above the load, the motor will turn. What do we call the torque, which is the maximum in a motor? Is it full load torque or pull out torque? Pull out torque. So guys, again, if I look at the picture and I tell me where the torques are, I know the answer. Now, those who got my books, guys, Brady, you guys, have a look. I've asked a lot of questions from it because in the exam, they ask questions from this. Right. We got maybe another half an hour maybe to go. Would you like me to carry on, or maybe worst case 40 minutes and then we stop, or do you want to stop for a break?
Carry on.
You want me to carry on and we can finish the theory in one video? I think that's easier. And I know you guys at home, you can quickly go to the kitchen, make a coffee and come back. I just got a glass of water here and I can keep myself busy with Coke as well. So I will continue. And look, guys, it's absolutely not very hard what we're going to do. And I bet you most of this you know. Motor protection. The motor can have two types of faults, short circuit or overload. So we need to protect the motor. For short circuits, you use fuses. Overload, we use an overload. That is the protection devices we use in the system. For short circuits, we don't need to use fuses. We can use circuit breakers as well. Now I'm going to ask the clever guys, which is all you guys, if you install a motor and you want to use a circuit breaker, and I spoke about it last week, will you use a C curve or a D curve motor, a breaker for a motor? While I'm Graham, a D curve. While I'm Jonathan, D curve. Right. When we install motors, we will also use coarse access protection. Motor which has got GM written on it, the fuse, or a fuse which is Q2 or R. The fusing factors for for coarse access protection, not close, but coarse. Now, because we have coarse access protection, we always need to put an overload in it. And I'm going to try to visualize it for you. Right, guys? Also, phase failure. The motor runs and then the red phase breaks. Motor must stop. Motor will not stop because there's still two coils running. Now, because this motor is now unbalanced, an overload will kick it out. We need to know that. And phase reversal, interesting one. There's a lot of speed drives you buy today which will only work in one direction. If you unfortunately turn the direction around, the speed drive will not work. So it's very important to know there could be a device which prevents you to change the direction to the motor. So that's why I said earlier, you change the direction of the motor on the motor, not at the plug. Right, guys? And the last thing we need to know is what happens if there's a loss in voltage. A no volt relay is normally used in an industrial installation. The relay will cut out and which will switch off the power of the system. If the power comes on, the no volt relay will kick in, but you physically have to start the motor again. So that is critical. We'll talk about that. So the type of protection for short circuits is either fuses for short circuits or obviously can use circuit breakers as well. For overload, I use either a thermal or magnetic overload. Now again, sorry guys, boring stuff. What's the difference between a thermal or magnetic overload? Let's go back to a circuit breaker. I told you guys last week, a thermal breaker has got a bimetal strip in it. A magnetic circuit part has got a coil in it. So here it comes. You can have a magnetic circuit breaker, I'll try again, overload, or a thermal overload. A magnetic overload has got a coil in it, and a thermal overload has got a bimetal strips in it, as you will know. So the one on the left, a magnetic overload, works with a magnetic field. A thermal overload works with heat. So as the current increases, it heats up the little element around a bimetal strip, and the bimetal strip will bend and open the overload. Now, guys, they will give you pictures like that, and they can ask you, what is that? You say it's an overload. But have a look in the left-hand side. This one's got a coil, yet the bottom is a dashpot with oil in it. So if you have a look here, the oil is just like a little barrier to prevent this plunger to go up as quick as possible. No, it will heat up and it will slowly move up. So this oil inside acts like a little brake. So the question in exam you need to know is, there's two types of overload, magnetic or thermal. Magnetic works with a magnetic field, magnetic, thermal, temperature. Which is the most common one used today? Magnetic or thermal? Can anybody tell me?
Thermal.
You all agree thermal?
Thermal?
Yes. Why not magnetic? Right. Let me go back again. A couple of moons ago, when I was still apprentice and also electrician on the tools, my job was to unscrew the cap, check the oil level, and push it back. So this was heavy maintenance. With this one, I just have to press a button to reset it. This one, yes, reset it by press a button, but I also had to check the oil. So this one was heavy maintenance. So this one died out. Today, the thermal one is most probably the most popular. And it's easy to set. You can set it at the current you wish, because that will just determine how far it can take before it bends, etc. So you don't need to know all that baloney. All what you need to know is magnetic works with a magnetic field, and as the motor gets warmer, obviously draw more current, the field gets stronger, and eventually the overload will trip. The thermal one draws current, the bimetal strip will heat up, bends, cut out. Happy with that? Cool. Phase failure. When one phase breaks, the motor will draw a little bit more current than the other phase, and the overload will do exactly the same job for us. So when the motor single phase, the two coils which are still operating will carry the current of the coil which doesn't work, and then the two coils which is now working will exceed its limits, and that's why the motor will burn out, or sorry, the overload will trip. Thermal overloads. You can use a magnetic one as well because both is operating the same. I just thought I'll put you two pictures in so you guys can see a bit more about overloads. Right, guys, I'm going to ask you a question. If 10 amps flows in the red, 10 amps flows in the white, 10 amps flows in the blue, is it true that all three phases are equal in size? Correct. That means there's no excess heat. If you put this on 5 amps or 2 amps over here, if that current is exceeded, then inside it will heat up and bend because the one coil is more than what is rated for. And obviously all three coils can actually open. Now, when it comes to phase failure, if this was 10, 10, and 10, and we break a 10 away, so now it becomes 10, 10, 0. This 0 is not 10, 10 here. So you take the 10 and you put 5 one side and 5 other side. So now you've got 15, 15, and 0. Do you agree that that 15 is more than 10? That's why the overload trips. That is just to give you an idea of an overload. Know that. Phase, no, magnetic and thermal overloads. Thermistor. Now, legislation say in 3000, chapter 4, you're welcome to go and read what motor size must have some form of overload protection. Is it any motor greater than 1 kilowatt? Any motor greater than 500 watts? Or any motor greater than 230 watts? I think it's 230. Oh, sorry, 370. I think it's 370. Can I tell you why? Does anybody know what is 1 horsepower? Run about 750 watts. So you'll learn, we're going to learn that later next week, that 747 is a Boeing, is approximately 1 kilowatt. Try again, 1 horsepower. So 746 watts equals 1 horsepower. Now, 1 horsepower, what is half of 1 horsepower? What is half of 750? Brady? What is half of 750? It's about 375. So any motor bigger than half a horsepower must have overload protection. Now, guys, you must know that. It's not in any booklet you find at your poly. It's in ASNZS 3000 chapter 4 under motors. You will find it there. Please go and tag that where it says run about 370 watts or bigger must have overload protection. Now, the thermistor. This thermistor is a bimetal strip we embed in the windings of a motor. When the motor gets hot, the bimetal strip bends and the motor stops. The thermistor doesn't work with A, heat, or B, magnetic field. I'm going to say that again. A thermistor doesn't work with A, heat, or B, a magnetic field. This little picture you see here where my mouth is. So guys, it works with heat. Heat, you embed it in the windings. As the motor gets hot, it bends and opens. Well done, you guys, Connor. So you must know this picture, the symbol as we call it. We call this a thermistor. Now, some thermistors work when it's hot, plus, and some thermistors work when it's cold, minus. That's why we say hot plus temperature, cold minus temperature. So guys, think about this. Your car radiator also got a thermistor in it. When it gets too hot, plus, it opens, and the red light will come on, and hopefully you will stop. Not what my son thought one day, it needs oil. He thought it was oil when he was still a youngster. So I trained him, no, it's not. It's when the motor overheats. So guys, when you see that little light goes on in your car, you stop, you add water, guarantee. Now, also a thermostat. There's a thermostat inside the oven. When the oven heats a certain temperature, it opens. That happens as well. Also a thermostat inside a fridge. When it gets too cold, it opens as well. So there's another option. It's either in the fridge or in areas where you would love to use it to do with up the temperature or drop the temperature. So positive means add heat, negative means drop the temperature. So that's good to know because it can be asked in the exam. But I don't think the up or down will be asked. They will ask you what is the purpose of that. They will ask you what does that symbol represent. Now this little things is called thermistors. We embed it in the windings of this motor. So when the motor gets hot, it bends and opens. Now you will learn in regs that if you got a motor to do with sprinklers and evacuation equipment, you're not allowed to use thermistors inside the windings, because when there's a fire and the motor heats up due to the fire, it must not stop the motor operation. So then certain motors cannot have thermistors or overload protection. Anyway, nice to know stuff. Let's try this puppy. Phase reversal. Guys, is a relay. When you accidentally swap the supply around, contactors will open and obviously the motor will not work. So if you have a look on my picture, there's a relay. As soon as you swap two coils around, technically you change the direction inside this relay. The relay will open the contacts and the motor will not start. You will normally see this relay inside a speed drive or a PLC, or even in the olden days as a relay, as what you guys can see here. The next one is called a no-volt relay. Now, a no-volt relay is normally in a cabinet where you've got contactors and motors and overloads, etc. When there's a drop in voltage, the power will switch off. There's a couple of reasons for that. You will learn next week that as we reduce the voltage of a motor, the torque will drop dramatically. In other words, the motor will get very weak. So it's very, very important to know that as soon as there's a drop in voltage, the motor can burn out because it's not as strong as it used to be. So we'll talk about that voltage issue next week. So you'll find out that on a no volt relay, there are selective screws, fitting little studs, which you can say what is the maximum voltage and the minimum voltage. If the maximum voltage is too high, it cuts out. If the drop in voltage is too low, it drops out. So there's parameters you can set to make the motor work properly. So this no volt relay, a lot of people is using in factories. The no volt relay is a little relay you can plug in, and when the voltage is too high, the magnetic field builds up and it opens the contact and the system cuts out. 3000 states, when the motor power gets switched off, or if an overload is tripped, the motor is not allowed to start by itself. You physically have to go and reset the motor to make it work. And that's why it's a manual action. Right, guys, and the last one is, if that motor is suffering like hell, the loads are too big, 9 out of 10 times, your overload will trip and need to be reset. So when the motor trips, it's not always, trip the overload, it's not always necessary that the motor draw too much current due to some windings which is buggered. It's possible that your loads are too big. So those who's in factories, you will learn this as experience. We are domestic sparkies. You will know if the lights don't work, check the circuit breaker, check the light switch, check the lamp. An industrial sparky will be trained what to look at when you do motors. So that's why the motor topic is always a bit of a harder one, because 98% of you guys do not get involved with motors. Right, we're just going to touch base on losses. The losses of a motor. If I give you an input and has a certain strength, and the output is the same, certain strength, then I'll sell my house, my car. No, I can't say I'll trade my wife in, but I will sell everything I've got, and I'll take all my money and I'll invest it in your motor you designed. So, gentlemen, ladies, you will never ever get a loss-free motor. The motor heats up, you lose power. So input power, output power. Now there's two types of losses we get: copper losses and iron losses. Okay, iron losses. Copper losses is due to the copper which heats up, and there's losses. Iron losses is due to the metal inside the motor. Now, iron losses is split up in two different categories. One is eddy currents and two is hysteresis. We'll get to that later. Friction. Friction is on the bearings. When the bearings turn and the motor is friction on the bearings, that is also heat generated. And the last one is windage. Does anybody know what is windage? And by the way, it's not the wind blowing outside. Okay, guys, if I give you a stator and I'll give you the rotor, the gap, the air gap between the stator and the rotor has got air inside. And as the motor turns, the wind inside causes friction. That's windage. So you see in my handbook, copper losses is I square R due to the copper which heats up. Iron losses is eddy current and hysteresis. I'll talk about that now. So, one in the exam, how do we reduce eddy currents? And B, how do we reduce hysteresis? You must know that. You must know what's iron losses. It is eddy currents or hysteresis. Now, it's all about heat. Now, eddy currents is currents inside metal. Now, a bigger the metal, the more the losses. So to reduce the losses, we use thin pieces of metal inside a motor. That will reduce eddy currents. So to reduce eddy currents, we use thin laminations. To reduce hysteresis, we use a specific steel. Now, what is hysteresis? The easiest to explain it to everyone in a very basic manner is if I give you a magnet and it's a coil, and the magnetic field keep on changing, south, north, north, south, north, north, south. The change of magnetic fields will create a bit of a friction, and that friction is called hysteresis. And to reduce hysteresis, we use a specific steel called silicon steel. Oh, it just rained in Wellington. Well, anyway, so hysteresis, reduce hysteresis by using silicon steel. To reduce eddy currents, use thin little pieces of plate inside the rotor, inside the stator, laminations. Is that clear to everybody? That is a question in exam. Friction is all about the friction, which is metal on metal, the bearings. Now, iron losses, copper losses, friction, and last one, windage, all adds up. And we call that the difference between input power and output power. That difference is called efficiency. Now, if there's a hell of a big loss, the efficiency will be very high. Sorry, very low. So the motor is not as effective as it should be. We will do that in a calculation next week. Right, reduced voltage starters. So I don't know if you guys ever heard about a star delta starter or an auto transformer or a primary resistance starter or electronic starter. Now, guys, they're going to ask you a couple of questions on them. But the good thing is they cannot ask you to draw them anymore. They can ask you what are the parts inside it, or what does it do? Come on, show you. So firstly, electronic starter. Electronic starter is a great device. It reduces the starting torque. It's also called a soft starter. It creates the motor to start, yes, softly, and it does it by frequency. A lot of the soft starters we have today is frequency speed motor drives, and they change the frequency on the motor to make the motor go. Now, one of the good things about it, a soft starter or an electronic starter, it would normally have a little display on the device where you can change the speed of the motor. It will tell you what happened with the motor a week ago, a trip, too much current. You can set it how long it will take to start the motor. You can also tell it how long it will take to stop the motor. It's a little computerized little drive which will start the motor. So that is the stuff we use today. But yesterday, we used to use a thing called, yes, star delta starters. But I don't want to go there. I first want to show you a DOL starter. Do you know what does DOL stand for? Does it say Dumb Ostrich Limited? Sorry, what did I hear?
Direct online.
Direct online. Now, a direct online motor will have a control circuit with a start button, a contact across it, a circuit breaker or a fuse, overload, stop, e-stop. Now, there's the main circuit. Now, one thing I would like to ask you in this control circuit, which you must know, what do you call that contact there? Is it A, the starting contact, B, the stopping contact, or C, the latching contact? Sorry guys, I just want to let someone in.
Auxiliary contact and
Right guys, that number A1 I just showed you is called a latching contact. Latching, or there could be another name, a retaining contact. You must know that. They're going to ask you that in exam. Well done, Brady. That component over here is called a latching contact or a retaining contact. So the start button is spring-loaded. If you push it in, if you take your finger away, it opens again. When you push it in and the contactor energizes, then the current goes through that contact which is closed, because that contact is its auxiliary. And when that closes, the current will go through there. And when you take your finger off, it stops. That part will stop, but the motor will still turn. So my question to you guys, a start button, is it normally open or normally closed?
Normally open.
normally open.
Well done. A stop button, is it normally open or normally closed? A stop button, normally open or normally closed?
Normally closed.
Well done. Gentlemen, ladies, that's what they ask in the exam. They ask you a stop or an e-stop is closed. A start button is open. A latching contact is open. They ask you technical questions like that. Now, guys, the main contact, when the motor draws too much current, the main circuit overload will open. And when that opens, it will also open the auxiliary in the control circuit, and that will force the contactor to stop. Because if this contactor do not open, that when that cools down, the motor will start again, and that's where you break AS NZS 3000. So guys, that is just a bit of a background, which you must know the parts of the contactors. They can ask you that. If you look at my handbook, I will ask you, what do you call that symbol? Or where do I use the symbol? Or what's the purpose of the symbol? Look at this one. It's a Ford reverse. How do you change the direction of a three-phase motor? Line 1A, line 2B, line 3C, forward. When it's reverse, A goes to A, B goes to C, and C goes to B. Is it true that this will change the direction of the motor? That
Yes.
is the overload. That is the latching contact. That is the latching contact. Right. That two parts. I would like to know, What's the purpose of that? A, is that a start button? B, stop button? C, contacts? Or D, electrical interlocks?
Electrical interlock.
Interlocks.
Yes.
Electrical
So
interlock.
guys, you must know that because the question could be theoretical. They can say to you, when the motor runs in forward and the coil energizes, F12 will open and you cannot reverse the motor. So when the motor goes forward, it's not allowed to turn backwards at the same time. What can happen if forward contact here and reverse contact here energized at the same time? A, motor will not
Short
work,
circuit.
or B, short circuit between two phases.
Short circuit.
Yes, but look what happens if this one is closed and line 2 goes to line 3 and that's also closed. Gentlemen, ladies, I don't want to be close by. Graham, well done, short circuit. Excuse me. So very important, the interlocks. Now, does anybody know what is that little icon there? A diode, or B, a mechanical interlock?
Diode.
I'll give you a hint. A diode has got a little line here.
Mechanical
So
interlock.
this, excuse me, it's a mechanical interlock. What happens? It's a physical thing we put between the two contactors. So when the motor goes forward, it cannot go reverse. When it's reverse, it can't go forward. So it's a mechanical interlock. So there we got electrical interlock, mechanical interlock. I believe this little symbol, they pop into the exam. Now that symbol can also be yeah between the two contacts. I put it between the coils, but you can also have it between the contacts. Depends where they want to put it. Doesn't matter, but know that.
On and off.
Beg your pardon?
Pero hindi naman kanya simple naman, di ba?
Hindi. Oh.
Right, guys, do you mind just to mute yourself? Ismail? Sorry, guys, I
Is
just
it like
want
a
to give
changeover
it.
switch?
No worries. No problem, Maris.
Okay, so guys, when you look at this, this is to prevent the motor to run and forward and reverse. This one is to prevent the motor to run and forward and in reverse also at the same time. So electrical interlock or mechanical interlock. Happy with that?
Yes.
So please, guys, remember this because this is a nitty gritty 20 questions you will get when you do motors. And you'll see that I covered all those questions in my handout, which you will do and practice every day. Shut up, so. Right, we're nearly there, guys. We're nearly there. And then we're going to call it a night. And then next week, we do all the calculations. The next motor I would like, and by the way, that is just an overload, and that is your electrical interlock, as I said. The next one I'd like to share is called a primary resistance starter. Or what I'd like to share here is that this resistors will reduce the voltage to the motor. So in other words, it's a voltage reduced starter. So you might put 200 volts on the motor, and when the motor runs faster, the contactor will cut out the resistance and the motor will be 400 volts. That resistance will determine a volt drop or give a volt drop to the motor, and that will make the motor go slower when it starts. So it will slowly pick up speed and it will go faster, 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 faster because that resistance, as it heats up, the resistance changes and the motor will go faster. When it hits a certain time with the timer, it closes and the motor will run normally. Now, if I give you that, that is called a start latching contact. It is a latching contact across the start button. And that is a timer auxiliary. It's a contactor which will determine when B closes, this part here, and short out the resistance, and the motor will run full speed. The last one of the lot, or the second last one, is called a star delta starter. Do you see my little interlock? Now, important, can
where do
anybody
you
tell me
use
what's
this
the
one?
purpose of that? Beg your pardon?
So the primary resistance starter, where we normally use that one?
Well, you can use it also
Example.
when you use a star delta starter.
Any
This
example? Where
examples, I'll give you this. And this is where I used to work in a factory, where it's got a big drum to turn. But when you switch it on, the drum is very heavy. So you put a resistance in line with the motor, so the motor will slowly start turning a load. And as the load goes stronger and stronger, it goes to delta straight away, and the motor will run full speed. It's to turn big loads. Now, guys, the primary resistance starter, I don't think any one of you will install one in your life. We talk about many moons ago, and we also talk about stuff which is dying out because today drives have taken all this. Even star delta starters. The motor starts 230, run 400 volts. Remember I said across the coil, 230, 400. When it starts in star, then when it goes to delta, the motor becomes three times stronger. Primary resistance starter, all what it does is it reduces the starting voltage. You guys okay with that?
So basically, the VSD is doing the job now.
Exactly. VSDs has taken all those jobs over. But because this is in a syllabus, you must know this, but not in detail. So this resistor here is either a resistor or physically a 230 400 volt contactor, which is a star delta starter. So that's why it's just good to know a bit of these things so that when they ask you a question, you know that it's a latching contact. And this one over here is also called electrical interlocks because the motor cannot run in star and in delta at the same time. Does anybody know why? What will happen? A, motor will stop. C, it will make one hell of a bang and then it will stop. Yes,
Brief.
fuses will pop because you create a dead short. And if you look here, if you show that star and delta, line 1 goes to line 2, which goes to line 3. So you've got a lovely dead short between all three phases. That breaker will blow within 0.4 of a second, very easy. Right. The last one is called a auto transformer. Now, if you look at this, the auto transformer control circuit looks the same as a star delta starter, but an auto transformer starter has got a transformer which will use tappings to a motor. So this transformer is another way to reduce voltage to a motor when it starts. So when I give you an auto transformer and I put it on 50% and the motor voltage is 400, what is 50% of 400? What is 50% of 400?
200.
200 volts. Yes. So when I put it on 50%, the motor will only have 200 volts to the motor, or the motor will have 200 volts. Now, does anybody know what is 75% of, if I use the next stepping, 75%? So guys, when I put it on 75%, I put 300 volts to the motor. If I put 900 or 90%, it might be 380 volts to the motor. So you can determine what voltage you put on the motor to make it start. Now, but yeah, it's a couple of questions. What's the purpose of this star contactor? The star contactor closes so the transformer can kick in. The delta contactor, when that closes, it bypasses the transformer and the motor will work properly. That is also called an interlock. Now, I told you about different voltages. Within the next minute or two, I'm going to give you a scenario and I'll prove it with a calculation next week. But before I do that, I've got a little quiz. Can anybody tell me which symbol will you use for A where it says E stop? Which symbol is an E stop? I'll give you a hint. Mushroom. Well done, Graham.
Number one.
Yes, E stop. You happy? What is B? Stop button. So right, Brady.
Number 2.
2.
Stop button. Well, obviously I'd already got one. So there we are. Stop button.
Number
Now
3.
that stop means push in and release. Emergency stop. Normally when you press it in, it stays there. It locks. Right, well done. There we are. Can anybody tell me which of the two which is left is number C, the start button?
3.
Number 4.
Number 3.
Or start.
C,
Okay.
3,
And the
and
latching
4.
contact?
Number
I
4.
want
4.
4.
So gentlemen, ladies, it's as easy as
Normally open.
no, the symbol. Yes, normally open. So sometimes they put normally open contact, normally close contact, and the start and stop button. They can give you any symbol. They can tell you what they are. So guys, a little bit of symbols you must practice. Go through it and have a look at my questions in my theory book. Don't do the calculations yet. Leave that for next week. Right, guys, we're nearly there. Now, what I want to share with you is an auto transformer. So if that motor in the middle has got 2 windings, or some auto transformers has got 3 windings, it all depends on the design. Now, normally when you have 2 transformer tappings, it's small motors, which is maybe up to 6 to 10 kilowatts. Any big motor bigger than that will use a 3-phase or a 3-phase or 3-coil transformer. So we'll put one here in the middle. But regardless, a 2 or a 3 winding transformer is good enough. So now my question to you guys are the following. If I put 400 volts on the motor and my tapping is now 50%, what is the voltage to the motor?
200.
200, right. If I put it on 65%, can anybody tell me what the voltage is? So I'm just going to take my calculator out. I'm going to type in here 400 times 0.65, 260. So I got 200 volts, 260 volts, or 400 times 0.8. It's 320 volts. So I've got a 200 volt option, I've got a 260 volt option, or a 320 volt option. Now, here comes the part you must know, because everyone in this class who sits this exam will get this question. If I take the motor and I connect that to a question which looks like this, and it says, if an auto transformer starter do not start at 50% tapping at 200 volts due to the load, what will you do? Will you take it to 65%? Will you take it to 80%? Will you get a bigger motor, or will you just connect the motor in delta? There's only one answer.
A.
Remember I said to you, if you guess, what number you're going to guess? A. Yes, it's A. So the moral of the story is, when the motor do not start on 200 volts, I use bigger voltage. If it doesn't start, you go bigger voltage. So this question states very clear in the exam. If the motor do not start at a certain tapping, you must go 1 tapping higher. Happy with that? You don't skip tappings, you only go 1 higher at a time. That is the answer I want you to remember. Now, just to recap, I did all the theory you should know. I just need 10 more minutes and then we're done. What I want to ask you guys is, next week, we're going to do motor calculations. Now, I love motor calculations. I think it's very easy. It's not hard. But I'm going to give you just a bit of a teaser what you must know about motors. And what's important about motors is, number one, and I'm not going to do it slow, I'm going to do it fast, is, could you remember 2 weeks ago, I talked about line voltages and phase voltages. I talk about star connection and I talk about voltage and current. Can you guys remember that? I hope so. That is something I want you guys just to brush up a little bit next week or this week for next week. Then, if I give you delta, and by the way, just to go on, there is also how to work out the power of the motor. And I've done that already with you guys 2 weeks ago or 3 weeks ago, but we're going to go through this again. But every time I'll tell you on the nameplate what we're going to try. Next one, delta. Line 1, line 2, line 3, line voltages. Line 2, 3 across the coil, phase voltages. Delta, there is your formula. Current stays the same. No, voltages are the same. Currents is not the same. And then there is your power formulas. Now, as I said, I don't want to spend too much time on this. I just give you a bit of a teaser what we're going to talk about next week. But here comes the critical part. And I want you guys to look at this, which I put in my book. If I give you kilowatts, there's a formula to work out kilowatts. That is your output power. If I give you a horsepower, you must know that 1 horsepower is 746 watts. If I give you this funny thing, what the hell is that? That is efficiency. Efficiency is output over input. Input is root 3 for 3 phase. Voltage, current, cos theta. Output power is include efficiency. So efficiency is power output over input. I'll teach you that lovely next week. The next one over here, which is flickering, is the RPM. On the nameplate, it's always called rotor speed. Slips is synchronous speed minus rotor speed over synchronous speed. Synchronous speed, how do we determine that? Frequency times 60 over pole pairs. We're going to practice that. Then the next one flickering now is frequency. You must know that. The next one flickering 3 phase. You must know it's 1.73 for 3 phase. For single phase, it's just without the root 3. Without the root 3. Then cos theta is just a value which is the power factor. Now, here comes interesting things, which I don't think you know, you've done before. That is IP rating. IP stand for what? What does IP stand for?
Ingress protection. Protection.
Ingress protection. Have you guys ever heard about international protection? Right. If you got a AS NZS 3000 book with you, go to Appendix G. G for golf. Appendix G. And in Appendix G, you'll see it gives you what is 1, 2, 3, 4, 5 for the first number, 1, 2, 3, 4, 5 for the second number, A, B, C, D for the third number, which is your additional number, and your last number could be H, D, J, W, V, F, and there's all the acronyms. But I don't want to teach you this. All I want to share is the IP chart is in 3000, Appendix G for golf. Right, now, this motor is connected in what? Star or delta? Have a look. Delta, 415, 8.52 volts. Sorry, try again, amps. If I give you this, guys, star and delta, can you see the current I gave you is a delta current? Now, I want the person, Graham Murray, take 8.52 divided by 3, please, if you've got a calculator. 8.52 divided by 3, and you can type in the answer for me in your chat show. 8.52 divided by 3. Well done. So the current in star will be 2.84 amps. Voltage is still 415. Now, Graham, take 4,000 and divide it by 3. 4,000 divided by 3. 4,000 divided by 3 will be 1,333. Now, well done. Thanks, Graham. So, if this motor is connected in delta, can you see that the current, the voltage, the power is to do with delta? If this values was written here, not there, then here would have said 415, 2.84, 1,333. So when you see a nameplate, it's based on the connection. Right, and the last part is your Newton meter. Does anybody what that represent? Is it voltage, current, or torque?
Talk.
Torque. There's a formula for that. Torque is P output is 2 pi for something which is wrong. And by the way, it's not a chicken pie. NR rotor speed, T for torque over 60. Now, guys, I'm going to give you the good news. Did you see all these formulas? This here at the top and this at the bottom. Did you know they all are on a formula sheet given to you? I'm going to show you something. The only thing which is not there is this horsepower, because you should know that. All the formulas is given. And I'm going to prove it to you just by doing one question. If I ask you what is the synchronous speed of the motor, synchronous speed, you go, shit, what is that? I say to you, it's the speed of the magnetic field in the stator. So the speed in the stator, there's a formula. Now, I don't care if you know that or not. You must know to find it on this piece of paper. There it is. Synchronous speed is 60 times F over P. But you must know the P is for pole pairs. Now, the little things like what I share, I don't want to go further. All I want to share, if I look at this formula sheet, efficiency is output over input. P output, 2 pi nt over 60. There's my torque formula. There's all my power formulas. There's my current and voltage formula. Guys, everything is there. Why do I have to learn the formulas? So all what I'm going to teach you, we're going to learn where we can find all the stuff. So when I ask you slip, you guys can say, man, where is that formula? It's over there. We must learn where to find it. I hope this helps you on the ideas what we're going to play with next week. So for tonight, I would like you guys to go home, and obviously you guys are all at home anyway, and go and practice the theory questions on motors. Please do it, practice it. And then next week, we can talk a little bit of theory and do calculations.